everybody, welcome back. I hope you're all having a great time at the summit or watching from afar. I really want to say thanks to all the users who are here in Twitch chat and kind of keeping us, on track and asking lots of good questions. Just keep that up. Hopefully we'll be able to answer all of those questions. So today I am here with Philip and Hira, and you both work with all of our kind of ML services. And today we're going to talk about comprehend, translate, and also about Poly. So why don't you guys each introduce yourselves and then kind of dive deep on what the feature is today.
Hi, my name is Filip Rogachevsky. I'm software development manager on Poly. I've been in Amazon for close to 1.5 years. We have two new very exciting features for you to present today.
So my name is Hira. I'm a solutions architect with the Amazon Lex service team. I also work with Poly, Translate, and some of the other service teams. I've been with AWS for just over 2 years, and my joy is to work with customers on one side and the service teams on the other to kind of bring that feedback back in.
Awesome. So today we launched a new feature, or two new features for Poly that are time-driven, prosody, and
asynchronous synthesis.
Asynchronous.
So in terms of the service, right? So Poly is the text-to-speech service, right? And today we support 52 different voices, 25 different languages, and we often talk about bringing.
Did you say 45 different voices or languages?
52.
52. Wow.
20. Yeah. And it's really cool because we often talk about the ability to understand speech, but we don't often talk about the ability to bring speech to applications. And there are some specific use cases where that's especially useful. But one of the challenges that customers have been facing is the ability to do long-form speech synthesis, right? So one of the things that we're talking about today is this asynchronous speech synthesis where we're doing 100,000 characters. In the past, when you had up to 1,500 or 3,000 characters, you could just use the console. But Tom Sawyer doesn't fit in 3,000 characters.
Right.
So what we're now announcing is the ability for customers to be able to go way longer than that. And in fact, Philip, you have something to show us.
Yeah. So as you said, Hira, we are launching two features. One of them is asynchronous synthesis. This asynchronous synthesis is a feature that allows us to synthesize text up to 100,000 characters. I have something for you, for all of you to see. One of my favorite tales when I was a kid was Snow Queen. Know that?
No.
So that's he's nervous, you can tell, right?
That's a Hans Christian Andersen tale. This is 65,000 characters long. And the new feature that we created allows us to turn this into speech. And that should, within a few minutes, be automatically uploaded to the S3 bucket that we choose. So this is the S3 bucket.
Okay.
Let me name the file. So it's a Snow Queen. There is an option for us to also choose an SNS topic to which information that the speech synthesis has finished is going to be published, and that can further integrate that with entire AWS stack.
And SNS is a simple notification service, and the way that works is basically you can push some JSON or other data into the topic, and you can say, either send me an email or let me subscribe a Lambda function to this or something else. So that way, when the asynchronous job is done, you can trigger some other thing, like maybe email the user or some other action.
Exactly. So the idea would be that this is part of, when we conceive of the feature, it's something simple like, hey, here's a job, right? But when customers look at it, it's part of a production pipeline, right? So the pipeline is something like when a file is dropped into S3, want to be able to synthesize speech from it, and that has some annotation. So for example, you can use speech synthesis markup language to get the additional annotation. And then finally, when the job is available, what you'd like to be able to do is to make it available to the next step in the stream. So for example, somebody was to QC it, or for example, use it in some other production step.
Awesome. And we have a quick question from the stream from Zoomage. So Zoomage asks, can I use Lex to just do speech-to-text translation? The service today is a bit more bot-centric. So we have AWS Transcribe, which I think that NYC Kid 80 just mentioned. And that's probably what I would use to do the speech-to-text side of things.
Yep.
And the LexBot isn't really intended to do the just-in-time speech synthesis. That's more of transcribe's domain.
Yeah, I think that along those lines, right, Lex is intended to be a bot-specific transcription. And so one of the features of Lex also becomes a challenge in this context when you try to use it for general purpose speech recognition. It's designed to work with the specific language that's part of the bot and the configuration that's provided. So if you're trying to do a general purpose speech recognition, the problem is that people wind up having to do a whole lot more configuration than they might want to do. So to the point, transcribe is a better fit.
And one of the advantages of Lex is you can actually output the voice using a poly voice.
That's right.
So bringing us back over to the demo here, we can see that...
the task is, or the information that I have is that the task is scheduled. Let's actually have a look at, oh wow, that's already completed. So I should see in my S3 bucket the file that I created. So let's refresh, and here it is, Snow Queen. Let's see if I can download that.
Just gonna adjust here.
Okay, it's downloaded, and let me actually look at the file. So
this is the Tale Snow Queen, which is this Hans Christian Andersen story. And what you've done is you've put the text of that into the Poly console and said, you know, read this to me in a very nice voice. Can I just brief interlude here before we play this, or is it playing now?
I think it's playing, yeah. So I'm not going to play the entire tale because it's 1 hour long.
It's almost exactly 1 hour. That's impressive. And also, MP3 1 hour long is only 20 megs. I never would have thought that. So the kind of interesting thing, and just a small request to both of you, have either of you used the Justin voice on Poly?
Yeah.
Okay, if you've ever seen the Stephen King movie It, or read the book, the clown in It sounds exactly like that Justin voice. So I just want to make the request now that we remove that voice entirely. I can think of no other purpose for it other than just terrifying children and myself. So Justin voice, never again.
Well, so you realize that once we put something out there, there's somebody somewhere who's got an investment in using that particular feature.
Well, we built a demo with Poly of actually taking all of the incoming Twitch chat, synthesizing it, and then playing it out.
Oh, that must have been fun.
And then I made everybody else have the Justin voice, and I gave myself the very British, formal, aloof-sounding voice whenever I type something. So that's pretty cool. I really like the ability to do more data than you could previously do. So now it's 3,000 characters for the synchronous invocation, and
100,000 for the speech related to asynchronous, and the SSML is extra to that.
Wow, that's really cool. I remember the way that we did this previously. I built an API called Read It. So it's api.readman.com/readit. And what you would do is you would pass in a URL. We would basically use NLTK, which is a Python framework, to parse the text from that page and get kind of the core content. And from there, we would actually have to split it. But you can't just split the text because Poly is actually intelligent. The way that it reads things, you kind of, it feels and sounds more human than just, if I go onto my terminal and type say -v Allen blah 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 blah. So with Poly, it's intelligent about what adjectives are being used, if there's a comma, if there's an exclamation point, things like that. And so if you split just every 1,500 characters or every 3,000 characters, you run into issues.
Yes.
So you have to split on kind of period boundaries or paragraph boundaries, and then Poly sounds a lot more natural. And I think that's kind of a cool thing that you're able to make the voices sound so natural. I say they because I never have you guys in person, so it's nice to have you here. It's kind of cool. I like that.
Yeah, in fact, one of the things that's interesting about Poly as a service is that it uses punctuation that is inferred from those sentences. So to your point, sentence segmentation is really important. The other thing is with some of the newer voices, we're trying to get more interested in the way that we use those voices. So if you look at Matthew, for example, as a voice, you'll see that it does a lot more nuanced pronunciation. And it does change it based on those punctuations a little differently than some of the older voices.
There's a principal engineer at AWS named Colin McCarthy, and I just butchered the pronunciation of his name, and I'm sure he's going to tweet at me in 5 minutes and yell at me. I apologize. but he was actually able to use IPA and in SSML to make his name be pronounced the way that it should be. And so if you ever have any kind of complex or specific instances of words that maybe Polly doesn't know how to say, like monobromo trifluoromethane or you know, whatever, you can actually put in the IPA and it'll go and say the right thing.
And this is also true for brand names, right? So if I want to pronounce this name a certain way, this service name a certain way, whether it's IPA, whether it's Xampa, you can use both and you can get it to pronounce things the right way. The other feature that we wanted to share with you today was the ability to do time-driven prosody, right? So one of the things that you can do with speech synthesis markup language is you can either speed up or slow down the rate at which the speech is uttered. But one of the challenges with that is, imagine that I'm doing a translation, I'm trying to fit content to a commercial, for example, right? I only have a certain number of seconds to work with. And so what I'd like to be able to do is to say, rather than mess around with the rates, to say, try this at 1.1, try this at 1.5, see what works, I can now say, with time-driven prosody, I can say, fit this to 20 seconds. So, Philip, do you have something to show us there?
So we have another demo, I guess.
Yeah.
This is a time-driven prosody one.
Let me show you how it works. I'm going to take something shorter. Let's say the paragraph introducing Polly. And let's go to the synthesized speech operation. Okay. I didn't copy that. So I'm going to download the. I downloaded the text introducing Polly.
So this is the normal speed.
This is the normal speed, yes.
And this is the Joanna voice, which is not the Justin voice, which is something I approve of.
And this is 27 seconds.
I'm going to use Justin just to do that.
Oh, don't use the Justin voice.
Especially for you, I'm going to do the Justin.
Oh, no.
Okay. So this is 27 seconds. How many seconds would you like it to be?
Let's go for, if we're going to use the Justin voice, we should slow it down because it's already super high pitched. So let's go for 40 seconds.
I would rather make it faster.
No. Okay, so, 15 seconds then. Let's see it.
Okay, let's make it 15 seconds. So for that, I need to use SSML. I'm going to paste my text here. And I'm going to use the prosody tag. Amazon max duration, you said 15 seconds, and Justin?
So I can't hear it, which is the sad part, or probably the good part, considering which voice you're using.
Okay, and here it is. So let's have a look at the duration of the file. This is, I think, this one.
Amazon Polly is a service that turns text into lifelike speech, allowing you to read applications and talk, and build entirely new categories of speech-enabled products. Amazon Polly is a text-to-speech service that uses advanced deep learning technology to synthesize speech that sounds like human voice.
This is literally the stuff of nightmares. I've already had a lot of trouble sleeping leading into this because of all of the blog posts and everything, and now you're just gonna haunt my dreams with this. You know, there's a service called Sumerian, and I'm sure if we had a clown avatar, and we put the clown avatar with the Justin voice, we would just terrify everyone.
Mission.
New mission.
Well, but, you know, it's really cool that you mentioned Sumerian, because that's exactly the kind of thing where this is a great fit for. So imagine if you were doing Sumerian with an English voice, and you had the gestures timed to that English voice. Now imagine if you went to German, and the words and the syntax are significantly longer, and what you wind up doing is having to then compensate for that by using prosody.
So doesn't Polly, maybe I'm mistaken, does it also output speech marks so that if you are doing something like that, it can go and actually tell you what mouth movements and things?
Yeah.
Okay. How does that work? Is that just another part of the API call, or do you have to request it? Or?
It's it's a parameter to the API call.
That's awesome.
Yeah, so one part of it is to be able to get those speech marks and the visemes, right? And the other part of it is to articulate that to a set of facial expressions. So if you have a vocabulary of facial expressions that you've created, so for example, when people say things like "I don't know," right? The gesture is usually "I don't know." So you can have your Sumerian host then gesticulate in the way that you've got your speech mark set up.
So we have a request from Twitch, which I guess I need to fulfill, which is they would like to hear it even faster.
Even faster? How much faster?
Twitch, how much faster do you want this to be? Just go ahead, haunt my dreams.
10 seconds?
Let's go 10 seconds.
Okay.
Oh dear. It sounds like evil babbling. Like, doesn't it just feel like it's embodied with all of this menace?
Yeah, what Philip and team are going to work on next is doing that in reverse.
So then it'll sound like Pink Floyd.
That's going to be longer, especially for you.
You could just do it in reverse. You can pipe it. You can pipe. So you'd go ffmpeg-i. You would put in that MP3, and then you can do -cav -r frame.
This is why the guy doesn't
flip
sleep.
It around, and it'll play it in reverse. And then you can pipe that out to AF play. I don't know why I know these things. I'm a really weird person, I guess. But listening to things in reverse is cool. So on that note, one of the things that we didn't really dive super deep on is the SNS notification, which is the ability to, with this kind of asynchronous API, I guess we did mention it, is the ability to ping SNS, which is a simple notification service, and go and say, hey, you know, whenever this job is done or this set of jobs is done, I want you to do something else. And SNS can actually be used to trigger Lambda. It can be used to send an email, a text message, all manner of things.
Let's just make something up, right? So let's say that we were going to take the content of this recording, right? And then what we would do is we'd use asynchronous speech synthesis to produce the MP3 file, reverse it as you suggested, and send it to your inbox every day. This is what we do with, of course, the right voice. That's the kind of pipeline that you could support with some of these tools put together. So you'd have the asynchronous speech synthesis doing one piece of it, the SNS notification then triggers a Lambda, the Lambda does the FFmpeg and the related transformation, and then when the S3 file is available, we can use either SMS or SNS to send a message to you.
All right, well, thank you so much for coming on, Philip. I really enjoyed seeing Polly. I'm gonna, later today, maybe we will do Twitch chat to Polly again. I'm not sure how that's gonna work with 300 people in the room. I'll have to multi-thread the output to the speakers, but we'll see if we can do that again, because we've done that in the past and people have loved it. While we're waiting for this to get set up, why don't you introduce yourself and tell us what you work on?
Great. Hi everybody, my name is Nino. I'm a product manager and I work on Amazon Comprehend. Let's talk a little bit about what that is, yeah?
Yeah.
All right, cool. So
sorry, before that, how long have you been in AWS?
More about me, all right. I've been at AWS just a little under 2 years now, and really excited, and it's great, and I love all the value that we're building.
Do you say that you worked on Comprehend? Because I don't think that's accurate.
I work.
You run the show for Comprehend.
Oh gosh, all right, okay.
So this is your opportunity. Any Comprehend questions you have, this is the person who can answer them. So
right.
I think you're going to talk about a new feature that we launched today, which is the syntax.
Yeah, and so I want to do that. And let's kind of go into that. But I want to first iterate for everyone that's watching, that's learning about Amazon Comprehend. Amazon Comprehend is really, it's a continuously trained natural language processing service. And I think the continuously trained part's really important in that, you know, typically to build an NLP service or a system that works really well for you, you have to collect a lot of data, you have to annotate that data, you have to train these models. There's a lot of work that goes into building a lot of high accuracy in terms of what you extract out of the text. Comprehend is a little bit like wrapping a data and a data science team in an API, right? So we really try to focus on that continuously trained and managed aspect, so allowing you to just really focus on your app and just get really high quality NLP results. You know, so the service itself is broken down, I like to say, into two parts. There's analysis APIs, so things like named entity recognition, so we'll actually categorize proper nouns. You know, Amazon would be an organization, things like that. We do sentiment, you know, so you can parse it all the way down to the sentence level and know if a sentence is negative or positive.
There's a really cool blog post that shows taking a Twitter stream and putting that through sentiment analysis. And then in a few Twitch streams, I think months and months ago, maybe right after reInvent, we did an analysis where we took the Twitch chat in real time and we had a little bot that would respond with the sentiment of the previous conversation, and then immediately everybody just started sending emojis. interesting result.
Yeah, no, totally. We actually ran in production in QuickSight this whole dashboard that showed, like, at reInvent we launched what people were saying and the things they were saying and what was the sentiment correlated with that. And again, amazing insight. You know, we actually have this on our blog as a formation template you could deploy, like with no code. It's pretty cool.
You just launch it.
So there's a sentiment API. We do key phrases, which is sort of like every sort of noun-based phrase.
And the key phrases is trying to like figure out what the most important part is from that sentence or text.
Yeah, I would say it's really noun-based phrases, right? So like, you know, like books or blenders would be key phrases we would extract, and sometimes you'll get an n-gram phrase, right? So if it makes sense. So key phrase, and then we have organization APIs that allow you to organize information. So this is topic modeling. With that API, it's great. You could just point it at a corpus of like documents, and it will actually organize them based on the keywords within them. It's an algorithm called latent derelict allocation, LDA.
Spectral LDA. It's also one of the SageMaker algorithms, right?
Yes, yeah. So you could do it yourself, and I love that you brought that up. So some of these algorithms, the Comprehend team writes some proprietary stuff. Some of these algorithms are also available in SageMaker. So it's really nice to kind of call out that if you're a developer and you really want to focus on your application, you don't have the time to invest into collecting data, annotating, training models, managing models, services like Comprehend, Translate, Transcribe are really great. You just sort of invoke them as an API and build these rich features in your app.
So I'll just give a quick anecdote here, which I've been told to stop doing by my boss. But there's within SageMaker, there's a built-in algorithm called Spectral LDA, and you can put in whatever kind of text you want, and it will get trained. You will get a model, and then you basically get an API that you can output, and you can say like, hey, I want you to tell me these results. But the advantage of Comprehend is, in order to do all of that, it is quite easy in SageMaker, but nothing is easier than saying import Boto3 comprehend equals comprehend, and then saying detect entities or start topic modeling job. That is tremendously powerful. I remember many years ago, before we had this API available, there was a framework in Python called NLTK, and that is how most people did a lot of this kind of analysis. And NLTK was like 6 gigs of data that you had to download, and I had to do that on an Australian internet connection once. Don't recommend that. 6 gigs of data you have to download just to be able to parse like the smallest piece of text accurately. And Comprehend, you just kind of shoot it over the network. You get your response like pretty much instantaneously.
It's awesome. Yeah, just through REST API, and then we support batch for most of the operations.
The batch operations.
And we actually, to your point, Randall, we have a lot of customers say, yeah, you know, the quality is awesome. And we love that. And then in some cases, it's not great, and they'll actually file a bug on us, and then we have to go fix that. So like I always like to joke and say, you can file bugs on our team that for quality of the NLP service itself. And when you sort of digest that, you're like, oh man, that's pretty cool. I don't have to worry about this anymore. So that's sort of Comprehend in a nutshell. Today, you know, as you said, we introduced the syntax API. The syntax API would be another analysis API, and so we had a lot of customers come and say, look, it's great that I can extract named entities, I can determine sentiment, but sometimes I just really actually need to go inside of that sentence at the finest granular level of that syntactical set of text and really understand what's going on. So it's a fairly common feature, but we're introducing syntax today. It allows you to effectively break up sentences into word boundaries, tokenized text, and then for each one you get a part of speech label. So is my screen on? Can I show this?
Yeah.
So it's a really simple, I'm going to show you the CLI today. So really just to kind of keep the demo really straightforward. But you know, in this case, what I did is I typed in, our customers love buying everything from books to blenders at great prices. You know, so this is actually one of our sample pieces of text in our portal. It's very Amazon-ish. So you can see here that what we did is we tokenized those words. So you can see customers here. You can see that, you know, we show you the offset, which is really important so you can understand where the word is in that document. And then we can associate the part of speech. So here you can see customers, of course, as a noun, love as a verb, and you know, buying, of course, as a verb as well. You know, these are really important features because, you know, we have customers say, look, I know that everyone's talking about like my KitchenAid, for example, you know, and I want to know what they're saying about it. You know, do they like the green one? You know, did it break? You know, those things are great, they never break. But so it's like they want to go into the sentence and start to build these really customized set of rules and conditions to look for.
And I mean, with that CLI as well, maybe programmatically you would do this differently, but within the CLI, if you're just looking for a really quick result, as an experiment, you actually have this JSON path query language that you can throw in, and that'll, maybe it's not JSON path, I can never remember what the actual name of that syntax is, but you can say, hey, just give me everything that's a noun and give me everything that has a confidence score over like 90%. And it's just like, it's built into the AWS CLI, so it's not hard to use at all. And then programmatically, when you get into that, I'm sure you do it slightly differently.
Yeah, it's super easy ways to parse the response object. And one more, because I thought this was actually a great example of why this API is important. I was just chatting with a colleague, and he said, we were talking about sample text of talking about a KitchenAid blender. Of course, you guys can tell I'm shopping. And he said, well, blenders and mixers, they're both the same. And I said, oh my gosh, they're totally not. These are two different products. And
wait, are they really not the same?
They're
though?
Totally different things. You should go check it out.
Oh.
And the important part here is that with Syntax API, I was able to actually parse the sentence and find out what are customers talking about. Are we talking about a mixer or a blender as it relates to that proper noun, KitchenAid? So again, it was kind of funny. We just had this real life example of why Syntax API is really critical to get you that fidelity that you need to understand what's happening in your text.
So how many different parts of speech can it detect?
So there's we subscribe to a universal body. There's 17 total parts of speech.
I can only name like 5
I know,
parts of
yeah,
speech.
you and I are riffing on this. There's like 5, but there's roughly 17. We actually have a list of them in the documentation you can go check out. So I urge everyone to either ask us on the Twitch Q&A or go to our Comprehend documentation.
Awesome. So Comprehend has been adding a lot of new features recently. I've really enjoyed the pace of development, and I'm excited to see what's coming down the line. And I was wondering, anything secret you can tell us about? We already heard about the new languages.
Yeah, no, nothing to talk about today. But what
I tried, everybody. I tried.
We have a lot going on, and we think that there's a lot of innovation we can bring to text analytics. I think that being said, our core goal is to make developers more efficient building text analytics applications. So we love feedback. I urge you to go to our forum to tell us about the features that you'd like to see or the patterns that you're working on. We're hyper responsive to that feedback, so that's kind of how we think about our roadmap.
One thing that I would really love to see, and maybe I'll work on this myself because it's something that I was working on the other day, is the ability to take that topic modeling job, and what it does is it outputs basically a CSV where you have the tags and you have the and we were just talking about this, I think. You have the tag, you have the term, and then you have the categorization. It'd be really cool. There's this visualization package in R called, I think it's called LDA Viz or something, and I think there's a port of it in Python. And you can basically take the output of these CSVs and visualize them.
Yeah.
And this is really helpful if you're just trying to get some idea of what your data looks like. So maybe I'll work on that. Maybe I'll make that an action item for me at the end of this, because I'd love to see that.
That's a deal. That'd be really cool. Nice.
And I'll write a blog post about it, which is my job now. So we have just a few minutes left before we got to move on to other stuff. I am in love with all of the ML announcements that we have had at the New York Summit, and I'm curious, what are some really cool customer use cases that you've seen for maybe not just Comprehend, but across all the services?
Some of the things that actually have me really excited are when we see customers start to stitch together the language services. So, these are customers who are saying, look, we've been building these applications for a while. We maybe don't have a data science team on staff, and we want to add these really rich machine learning-based features to our app. So they're coming to the language services space. We got the 1 minute mark. And what they're doing is starting to stitch these together. For example, they're starting to transcribe phone calls, turning phone calls into text. They might actually translate some of those, to use translation so they can build multilingual solutions. And then all of this flows into, you can imagine a series of Lambda functions, basically building a pipeline. And then all of this flows into maybe Comprehend. So now they're saying, okay, I want to transcribe the call. I want to maybe translate it. More importantly, I want to understand what's happening. And they're using things like topic modeling to see, hey, yesterday we got 1,000 calls. Boom, now they have a KPI dashboard that shows all of the issues customers are having and how they're trending over time. And these were like so easy to stitch together, and there's no data collection, no work, no training. It's pretty cool.
I love it. And if you're going to stitch all that together, step functions is a pretty good way of doing it. And you can put in little custom API calls and manual steps. It's all well and good. Thank you so much for coming today. I will see you later today. Okay. We've got another session in a couple minutes, so don't leave. We'll be back. Thanks again, everybody, and have a great day.
Thanks.